So as always, when we begin a question, we want to read the question sentence. So the question sentence or question phrase that starts off with the who, what, when, where, how many, which of the following, all that good stuff. So here it says, how many full crates are needed? Okay, sounds good. So how many full crates are needed? All right, perfect. So with that, we want to know how many full crates. And when we take a look at our answer choices very briefly, everybody, which one of these answers isn't a full number, a full amount? Yeah, B. B is not a full amount. How many full crates? If we are asking for the number of full crates, is having half of a crate an acceptable answer? I don't think so. B would not be it for me just looking at this. And again, everybody, the numbers could change in different types of problems. So just looking at this logically, B wouldn't work before I even do the math. So here we go. A bakery uses 5 dozen eggs. If each crate holds 30 eggs, how many crates are needed? Okay, cool. So we see that we have 5 dozen eggs. And we want to see how many crates we can make with these 5 dozen eggs. Each crate is 30 eggs. So each crate equals 30. Everybody, when we are trying to see how many full crates are needed, what operation are we doing? When we have the total eggs and the 30, what operation are we going to do? Yeah, we're going to divide here because we're trying to see how many groups of 30 eggs we can make because every crate is 30 eggs. So we want to know how many groups of 30 we can make out of 5 dozen. The only problem is we don't have the actual number of eggs. This says 5 dozen. The conversion is 1 dozen equals 12. So with that, everybody, we're going to multiply the 5 dozen by 12 to get the actual number of eggs. And when we do that, 5 times 12, that's going to give us 60. So now we have 60 eggs. Every crate is 30. So we'll do 60 divided by 30. Everybody, how many times does 30 go into 60? That is going to be 2. Yep, that's correct. And that's why the final answer is 2. Answer D. Let's go. All right, and that's time. My party people, go ahead, put those answers in. Put a question mark next to your answer if you feel like you might be taking a guess. All right, let's give this next one a go. So let's get the timer out of the way and let's write everything out. We got this. So the slope formula, I'm going to copy it over from the previous question. So let me just do that to save some time here. Booyah, there's our slope. And let's get to work. So I'm gonna just be, the way that you might be thinking about it in terms of, hey, this first coordinate that we see M, that'll be my x1, y1. And then the N, as in Nancy, we'll mark that as x2, y2. We'll do it just like that. So when we plug everything in, notice I'm going to say this a million different times, but I'm glad it's helping you maintain that consistency. Again, be consistent. Put the y and the x of the same coordinate over each other. That's what being consistent means. So let's plug it in. We have the y2 and x2. We're going to have 5 and negative 4. 5 is the y, negative 4 is the x. So we'll plug that in above each other. 5 over negative 4. Sweet. We'll still write down the subtraction symbols. And then we'll continue on by writing the y1 over the x1. y1 is negative 1, negative 1. And then the x1 is positive 2. So now that we're here, now that we've plugged everything into the right place, now it's really going to be a matter of calculating correctly, noticing the double negative, working with the negative, and we're good. So let's move this over to the left side so we have a little more room to work with. We have 5 minus negative 1. 5 minus negative 1, that's going to be 5 plus 1. Everybody, 5 plus 1, that's going to give us 6. Exactly. Next up, we have negative 4 minus 2. If we are at negative 4 and we go back another 2, so take away another 2, what are we at? Correct. We're at negative 6. Negative 6, not negative 2. Because remember, negative 4 means we're at 1, 2, 3, 4 negative. Take away 2 means you go back, so negative 2 more. So that'll be negative 6 total. I got you, no worries. So that'll be negative 6 right there. And everybody, when you divide the same number over itself, 6 divided by 6, that's going to give us what? Yeah, it's going to give us 1, but because we have a positive over a negative divided by a negative gives us a negative. So that will be negative 1. And there we go. There we go, my party people. Look at that. So at this point, whose confidence is now like really starting to set in? Like you're really feeling this. Like you are understanding what you're good at, where your most common mistakes are, and you know how you're trying to think about it in the next iteration and next iteration. Like who's actually getting excited that you're making these mistakes less often? See, that's what I'm talking about. This is where things really start to set in stone in terms of your fundamentals. I talk about fundamentals all day, but the thing is, you can't build a house on mud. And that's why your foundation is so important, because most of us have tried to in the past, just take problems, try problems and move on. But if there's no real conceptual foundation, then it's almost as if you're just going through a rhythm and not really growing. So I got y'all. So with that said, my party people, we got a couple more to try. I want to go ahead and bring the page back up to here. Let's go ahead and do this.